How do we find the value of m and n in the Pakistan Olympiad math question? Let's find out. To pause this video a little, try working it on your own and then play it and then see how much you are able to find the value of m and n. 2 to the power of m minus 2 to the power of n equal to 2016. To find the value of m and n, you can find out from that expression two things. That from this expression, you can see that 2 to the power of m is what is greater than 2 to the power of n, right? Because 2 to the power of n is subtracting 2 to the power of n. So that simply tells me that my m is what is greater than n. So if m is greater than n and I'm able to remove that inequality sign, then I'll have my m to be equal to n plus a constant. Now I'll take this to be an equation 1. Now looking at that equation, I can now substitute that value of m equal to n plus k into the initial expression. And if I do that, I'll have 2 to the power of n plus k minus 2 to the power of n to be equal to 2016. So what do I have here? I have this expression to now be equal to, this whole expression can now give me, considering the laws of indices here, with 2 to the power of n plus k, I can have that expression to be 2 to the power of n multiplied by 2 to the power of k, right? Minus 2 to the power of n, and this will be equal to 2016. So from this expression, you can see that 2 to the power of n is common. So if I bring out 2 to the power of n, right? And that will give me this whole expression divided by 2 to the power of n. I'll have this to become 2 to the power of k minus 1, and this will be equal to 2016. So how do I simplify this? To simplify this, I'm going to look at the factors of 2016. What are the factors of 2016? The factors of 2016 is 2016 will give me 32 is a factor, right? 32 multiplied by 63. 32 multiplied by 63 will give me 2016. So 32 can be equal to 2 to the power of 5, while this can be equal to 63, because we can't find that to a given base. So that expression can now give me 2 to the power of n multiplied by 2k, 2 to the power of k minus 1, and this will be equal to 2 to the power of 5 multiplied by 63. At this point, we're going to equate the two equations, considering the fact that this is even, right? If this is even, 63 is an odd number, right? From the left hand side, we can see that 2 to the power of k minus 1 is what is odd, while 2 to the power of n is even. So we're going to equate the even to the even and the odd to the odd. Equating the even, we'll have 2 to the power of n to be equal to 2 to the power of 5. Since they have same base, then our n can be equal to 5, right? And that is a solution. Now equating the odd, we'll have 2 to the power of k minus 1 to be equal to 63. Now 2 to the power of k will be equal to 63 plus 1, right? And that will give us 64. So we'll have 2 to the power of k to be equal to 64. Now 64 can be equal to 2 to the power of 6, right? So 2 to the power of k equal to 2 to the power of 6. Same base, then k is equal to 6. This is also the value of the constant given to us. Now, how do we find the value of m? Now, recall the initial expression we were given that m equal to n plus k, which is equation 1. We insert the value of n and k in that expression, then we should be able to find the value of m. N plus k, and from our expression, our solution, the value of n is 5, so we'll have our m to be equal to 5 plus 6, and then our m is equal to 11. So the value of our m and n is equal to m, n is equal to 5 and what? And 11, which are the solution to that math expression given to us up here. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.